Good morning, everybody. Morning, Michael Paw. It's Wednesday. So the way that you see your code displayed in UB Learns is fine, as long as when you open up the file, the M file itself, then there shouldn't be an issue. Yeah, ignore the PDF view on UB Learns. It's fine. It lets you know that your code looks, or your file looks the way it should. In MATLAB, when you're writing code, if you notice there's like a vertical line in your script file window, that vertical line indicates where your code will essentially be chopped off to go to the next line when it's as viewed not as an M file. But as long as your code is submitted as an M file, it's not an issue. Morning, Benny Levin. Ooh, Michael gets his second COVID vaccine dose? How did you get a COVID vaccine dose? That's awesome. Wait, are they giving them to students? Are they not giving them to students? I know instructors can get them. Okay, that's awesome. You mean yours didn't get canceled? I really hope the vaccine distribution process becomes a little better, a little smoother in the next month. I don't know though. We'll see. It's a lot of logistics to go through. Yeah. You can use a semicolon. You're not going to be graded. You're not going to have points taken off if you don't use a semicolon. You're not going to have points taken off if you do use a semicolon. As long as your variables show up in your workspace when you run your code, that should be fine. What it says in the homework document, that's Dr. Ali's preferences. My preference is to always put a semicolon all the time. Every of the time. But you're not going to have points taken off if you don't. Sorry about the confusion. See how many people we got here right now. Oh no, I closed out of my Twitch. $19! Woohoo! So don't put the clear command in your code. You can always clear it from the command window. That's fine. But do not put the clear command. When I open up your code, my workspace will be empty. So that when I guess the TAs and graders, not gonna lie, I don't have time to grade everybody's assignment manually. But yeah, when your code is opened up on my end, my workspace will be empty. I will run your code. So if you want to make sure that your code really truly works, clear your workspace from your command window and then press run on your file again. But don't put clear inside, then it won't work. Okay, 11:30. Woohoo! So Flora, are you Ben? When you download your code, remember when you run code inside of MATLAB, it needs to be in your current folder. So if you download it and it's in your downloads, that's fine. You just need to move it to your current folder or move your current folder to your downloads. That's it. If you do run it though, and it pops up a dialog box that says code isn't in, or script file isn't in your current folder, would you like to change your current folder or add to path? You can always click either of those options and it should work. I like to change my folder. Anyway, it is 11:30. Let us go ahead and start learning how to write function files. So I had some videos that you guys were supposed to watch on Friday, and I went over what a function is. I went over function calls. Today, I want to go over how to write a function. In general, writing functions tends to be a more challenging thing for students. So I want to focus on a lot more practical stuff today. So I'm not going to re-go over the stuff in the videos. Just note that a function is an isolated set of code. And you guys have already been using functions, like your math functions. When you type sine of pi over 3, this is a built-in MATLAB function. Say x. Pi over 3 is what you are sending to the function. Sine is some MATLAB file that exists somewhere else that contains all of the code in order to calculate the sine of something. So you're sending that file, a value of pi over 3, and it's calculating sine and then giving you back the answer to store in x. But the code to calculate sine is completely separate. It's isolated. We don't have to deal with it. We don't have to worry about it. It is nicely taken care of behind the scenes. As users, we can write our own functions. This is the file that MATLAB gives us as a template for how to write a function. And I don't really like the template. I'll show you guys where to find it. I don't really like it, but it does show all of the components that are required when writing functions. So this first thing here, that's our function definition line. All functions start with that. And then we have some comments that give us some context about what the function does. After that, we have some code. So here's just standard code. It's just MATLAB code. That's it. And then it has an end. Every function has an end. We will see ends in a couple different places. Every function has an end. Every if has an end. Every switch has an end. Every for has an end. Every while has an end. So we'll see end a couple different places, but it just indicates that this is the end of the function. Those are my components. I've got a function definition line. It's my first line. I have some comments. I have some code, and I have an end. So we're going to piece together all of these items to write functions with some examples. So let's go ahead and write our first function. Oh my goodness, you totally are right. I forgot to change my header all week. I will have to remember to change that. I was planning on changing it, and then I clearly did not. Thank you, Mitchell. I'll change it. In theory, I should be able to change it right now. Oh, I know what I need to do. I got this. I got this. Week 2. Scripts and functions. Woohoo! Woo! My last lecture of the week, and it's changed. Thank you. Okay, let's go ahead and write our first function. I'm going to stay in my notes for a little bit, and I have 2 examples that I want to get through today. Oh my goodness, I forgot to clear this. Go away. Go away. We'll leave it over there. Sorry, I cleared all the other notes. Clearly not that one. Okay, so here I have a basic prompt. It says, write a function that calculates the surface area and volume of the frustum of a cone. Your homework is going to be a little more descriptive. but in general, we're writing a function. The frustum of a cone looks like this. It's just a weird word for the cone with the top chopped off. And we have some R1, R2, and H. So it's defined by a couple parameters. And I want to write a function that calculates the surface area and volume, given these equations. So these are my equations. Before we even get to writing functions, there are 4 questions we really want to ask ourselves. And they're listed here. So there's 4 things we want to address before we even start writing our functions. First, it says determine a descriptive name for the function to represent its functionality. We can name our functions whatever we want. In the homework, you are going to be told what to name your functions so that all of you guys have the same function name. But in reality, you can name your function whatever you want, as long as you are following the same rules as naming variables. Which means that you need to use letters, numbers, and underscores. And it also should be descriptive. It should have an indicator of what the function does, but you really can name it whatever you want. You can name it function1. Obviously, you can't use the keywords either. Same things as naming variables. The second thing you need to identify are the input parameters. What input parameters are appropriate? Input parameters, they're just variables that are accessible within the function that define the data that is needed in order to perform the calculations. So essentially, here you're asking yourself, what information do I need? Specifically, what information do I need in order to perform these calculations? In general, you can have any number of input parameters you want. You can have 0, 1, 2, 3, 4, 5, 6, 7, as many as you want. Just keep in mind, you need to type all of those input parameters, and it should be practical. Once you know what information you need, then we can figure out what our output parameters are. Once again, output parameters, they're just variables. They're created within the function, and they're going to store the results of my calculations. So for our output parameters, we're essentially asking, what am I calculating? What am I calculating? What information should this function do? What should it calculate to send back? For the sine function, it sends back the final answer. So a lot of what output parameter is essentially, what is my final answer? You might have no final answers. You might have 0 final answers. You might have 1, 2, 3, 4. Same thing. You can have as many output parameters as you want. Once again, it should just make sense. And then lastly, we have to write the function body. So this is where we are actually writing our code. Our function body is our MATLAB code. Ooh, I want to write something else there. A couple things to note for writing our function body. We can use any valid MATLAB code. That's not a problem. However, our input parameters must be used in our calculations. So remember, input parameters are variables. They need to be used in our calculations. That means they need to show up on the right-hand side of our equal sign. They need to show up in our calculations. The second thing is the output parameters also are variables. Those need to be defined in our function. So they need to show up on the right-hand side of our equal sign. And then we can have as many other variables as we want. But this is how, essentially, this defines how we are going to use our input parameters and our output parameters. Okay, so let's go back to our frustum example. Weird word, but let's go back to it and answer those questions. So first question, determine a descriptive name for the function to represent its functionality. Good question. So input parameters need to show up on the right-hand side, output parameters need to show up on the left-hand side. And we will see that, I'll point it out when we actually write our code. But that is definitely something that needs to be kept straight. You'll get used to it. So we are calculating the surface area and volume of the frustum. We could say calculate SAV, frustum, whatever we want. I'm going to name it frustum SAV. Frustum surface area and volume. That's just what I chose. In theory, you can name it whatever you want. But like I said, for your homework, it's going to be given to you. Once I know the name, then I can determine my input parameters. When we are looking at our input parameters, remember, we're asking, what information do I need? So in order to calculate the surface area and volume of a frustum of a cone, I need these two equations. In order to do these two equations, think about what your variables are. So I've got pi, R1, R2, R2, R1, H, pi, R1, R2. Pi is a constant. So I don't really need the value of pi in my function. Okay, that's just a given. I know what pi is. For the rest of them though, R1, R2, and H, I don't know what those values are. I need that information in order to do my calculations. So I need to know what R1 is, R2 is, and what H is. That's a good indicator that those should be your input parameters. What information do you need to do these calculations? I need to know what R1 is, I need to know what R2 is, and I need to know what H is. So I'm going to choose those as my input parameters, R1, R2, and H. My third question is, what are my output parameters are going to be? Essentially, I'm asking, what am I calculating? And I know for this function, I am calculating the surface area and the volume. So surface area and volume. Those are going to be my outputs because that's what I'm trying to calculate. And then lastly, write the function body, do my calculations. I'm going to not write that down right now, and we'll jump over to MATLAB. I know you guys can't see these both at the same time, but that's okay. Hopefully you remember the discussion we just had. So let's go over to MATLAB and actually write this function. So in order to write a function, it's just another M file, so you can press new script. If you want the function template for MATLAB, you just press new and then function. It will give you the template. I don't really like the template, so I'm just gonna start from scratch. I think it's a better practice. Also, they didn't have a template when I learned how to code in MATLAB. Okay, so let's write our function. In order to write a function, we start with the word function. Shows up in blue, nice. This needs to be your first line. When you're writing a function, this is the first line. It needs to be next to 1. You cannot have any comments above it. You cannot have any code above it. It needs to be line 1. It needs to start with the word function. Next to the word function goes open close brackets. Inside of these brackets, we are going to type the variables that we're going to use to store our output. So for this function, I have two outputs, S, A, and V. These are just variables. I can name them whenever I want. I could say surface area. I could say volume. They're just variables. Name them whatever you want. So inside of your brackets, you list out the variables that are going to store your outputs. What are you calculating? I am calculating the surface area and I am calculating the volume. Separate those by commas. Then I have equals. After the equals, I type the name of my function, which I decided I would call it frustum SAV. After the name of your function goes open close parentheses. So remember, in programming, everything needs to be exact. Like when you do multiplication, you need to do the asterisk. Like everything needs to be exact. So when we are writing our functions, we need to have all of this proper syntax. We need the open close brackets. There's an exception to that. I'll talk about that later. We need to have the name of our function. We need this equal sign. You don't need all the spaces except for after function, but we need to have the right syntax. After the name of our function goes open close parentheses, inside of those parentheses go our inputs. So I need R1, R2, and H. They're just variables. I can name them whatever I want. Rad1, Rad2, height. and then end. There we go. That's the start of my function. Remember, this needs to be the first line of our code. There can be nothing above it. So before we keep moving on, I want to save our function. So I'm going to click save. And MATLAB gives you a recommended name, a recommended file name when you save your functions. Notice the recommended file name that MATLAB gave me is frustum.sav. Frustum.sav was the name of my function. When we save our functions in MATLAB, we need to save the file the same name as our function. So if I have a function called frustum.sav, that means the file should also be called frustum.sav. Notice if I change this, if I change the name of my function, MATLAB gives me a warning. It says function name frustum.sav changed is known to MATLAB by its file name frustum.sav. So when we save our functions, when we write a function, it needs to be located in a file that has the same name. So the M file means it's just a MATLAB file. It means it's opened in MATLAB, it's executed in MATLAB. If you notice along the side here, it's kind of small for you guys, but the icon changes. This function word right here makes it a function file. The brackets are specific to the outputs and the parentheses are specific to the inputs. Yes, that is exactly how it needs to be. Otherwise it will be incorrect. Shnatuba, ask your question later on, because I'll probably forget it. Okay, so we have our first line of our function defined. Now I'm going to go ahead, I'm going to skip over the part where we do comments. I'll come to those at the end. And let's go ahead and write the code for our function. So inside of this function, I am literally just going to do my calculations. I'm going to calculate surface area. And the function, or the calculation to do that, is pi times give me half a second while I finish this. Okay, there we go. There's my nice long equation. For surface area, same thing for volume. I just have a different equation. 1/3 times pi times height. Does anybody else have a blurry screen? Thank you, Benny. It might be because you don't have the bandwidth. If you choose low latency, it should help that, Cupcake Panda. Go into settings. Thank you, Benny Levin. Okay, so Benny Levin says, is it okay if our input variables will just be R? Yeah, so you can name these. These are just variables, whatever you want. I can change it to R1. I can change this to R2. This to H. It just makes things simpler. I can change this to SA. You can name them whatever you want. Just make sure it makes sense. Okay, so here I have this function. Notice I didn't define what R1 is, R2 is, or H is. R1, I don't know what it's going to be. R2, I don't know what it's going to be. H, I don't know what it's going to be. What I'm going to assume, though, is that they are going to store appropriate numbers. Okay, so we have our function, we save it. Let's go ahead and use it. So when you write a function, you can't press run. If you press run on a function, it's going to tell you this. It's going to say not enough input arguments. So when you have a function file, you can't run it. What you do is you call your function from the command window or from a different script file. So I'm going to open up a new script file. I'm going to save it as test.m. And inside the script file, I'm going to call my function. That means I'm going to use it. When you use a function, when you call a function, you just type the name of the function, followed by open close parentheses, and then you send it what information you want. So if I wanted to use the sign function, I would type sign and open close parentheses, and then send it whatever value I want to calculate the sign of. Same thing for our frustum SAV function. I would type frustum SAV, open close parentheses, and then I'm going to send it some data. So let's say 2.5, 3.2, and 4.4. And then, like we know in the past, we should assign everything to a variable. This function here returns 2 pieces of information. So if it's going to return 2 pieces of information, I'm going to do open close brackets, and I'm going to create 2 variables that are going to store my results. So surface area and vol. Notice the way I use my function looks very similar to the way I created my function. Okay, so now I can run test. Test, what happens when we call a function are these values are going to be used inside or for our input parameters. You just click and drag. So I clicked here, dragged it down. So that means R1 uses a value of 2.5. R2 uses a value of 3.2. H uses a value of 4.4. Using those values, it's going to do this calculation, then it's going to do this calculation, and then whatever it calculated, whatever value for SA is going to be used for surface area, and whatever value for V is going to be used for vol. And that calculated 131 and 112. So let me go ahead and illustrate this in using the debugger. So I'm going to run this code and execute it line by line. So here I'm going to execute this code. I called a function. When you call a function, what happens is MATLAB is going to go to that code inside of the function. Notice in my workspace here, I have a workspace specifically for my function. Remember, functions are completely isolated. We don't really see or care about the code inside. So here I'm showing essentially what is happening inside of the function. H was assigned a value of 4.4 because 4.4 was the third input to my function. R1 was assigned a value of 2.5 because that was the first one inside of my function. R2 was assigned a value of 3.2. So notice R1, R2, and H in that order. That means this is going to be used for R1, this is going to be used for R2, this is going to be used for H. Wilcox, I'll answer you in a minute. And then inside my function, it calculates my value for SA using those values, using 4.4, 2.5, and 3.2. It calculates SA as 131. And then it's going to calculate V using those values as well, calculates a value of 112. When I click end, when I get to the end of my function, this workspace is going to disappear because it's completely separate. It's isolated. I don't care about what's happening inside as long as it does it correctly. So that when I go back to my script file, all I care about is that surface area contains the value that was calculated for the surface area, and vol contains the value that was calculated for volume. So the variables inside of my function are completely separate from the variables inside of my script. So Wilcox, you can technically call your function using just the right-hand side. However, if you have more than one output, you will only get the first output. So it only outputs surface area and not volume. So if you want to be proper and appropriate, you want to make sure that you have the left-hand side as well. Benny Levin, can you use, yes, you can use the same variable names inside of test as you do. So I could say SA and V inside of my script file. I will just have SA and V. But keep in mind that SA here is completely separate from SA here because the variables in my test script file are isolated and separated from the variables inside of my function. Nick, about it that way. So a function, it's not a stored equation, it's a stored set of code that a script file can execute. That's a good way to think about it. Okay, so I calculated the surface area. So I'm gonna say surface area 1, volume 1. The nice thing about functions is I can just copy, paste it, and automatically calculate with a new set of numbers. So let's say I wanna do it with R1 of 3, R2 of 4, and a height of 5. Just change this, and now I can run it, and I can get a whole nother set of values. Without having to copy and paste and change everything for this code. Same thing, I can get another set of values. 3 with another 12.7, 19.3, and 8.5. Now I have 3 sets of values. So these brackets here are used to store my results. So this function returns 2 pieces of information. So that means I need 2 variables to store my results in. They need to be in brackets, otherwise it's gonna be incorrect. So if you don't have the brackets, MATLAB thinks these are 2 separate lines of code. It thinks you're trying to print out the value for SA_3, and then you're trying to just assign V3. So it needs to be in brackets, otherwise you won't get both pieces of information. Okay. So some vocab, there we go, that's the word I was looking for this morning, vocab. This is a function call. When you use your functions inside of a script file, that is a function call. Okay, let's go ahead and finish up our function. So I mentioned this is our first line of our function. It's our function definition line. This is our function body, and this is our end. We also have some comments that help give context to our functions. The first line of comments that your function should have is called the H1 line. And it always starts with the name of your function in capital letters, followed by a very short description of what your function does. So frustum SAV calculates the surface area and volume of the frustum of a cone. It doesn't need to be long, it doesn't need to be complex, just a short description of what your function does. Then here is where you might add those comments that I mentioned in your script files of your author and the date. No, the function file does not need to be opened. I can save this, close it, test it, it still works. As long as your function is in your current folder. That's a very good point, a very good question. Your function needs to be in your current folder. If frustum SAV was not here, then it would say I can't find that function. So for our comments, the first line is your H1 line. It just is a short description of what the function does. There are some additional things I want you guys to add to your functions. I want you to identify your use case, which notice when we used our function, it looked essentially the same as when we wrote our function. So when you type in the use case, just literally copy and paste that first line down. That just tells us how to use our function. And I'll mention why we want to do that in a minute. I also want you guys to identify what your inputs are. So here my input is R1. This would be the smaller radius. R2, the larger radius. And then H, which is the height. Come on. And then lastly, I want you to identify your outputs. In here we have SA, which is the surface area, and then V, which is the volume. So remember, your functions are isolated. That means when you're using a function, you're typically not, like you don't know what the code is. When you type sine of pi, you don't know the code that's taking place inside of sine. All you really want to know is how to use it. How many input arguments do I need? How many output arguments are going to be returned? So that's important that we have these help text lines, these lines of code. Is that how you do multiple? If that's the way that you do multiple comments in MATLAB, sure, go ahead. I typically just do one on each line. You can also use these buttons up here. So these buttons will comment out a whole section of code. If that's how you do, Mitchell, if that's how you do like group comments, that's totally fine. Like I said, I learned MATLAB back in 2009 was my first class in MATLAB. So they've made improvements since then. So it's important that we add these comments so that when people use our functions, they know how to use them. If you watch the videos, one of the videos was how to get help in MATLAB with functions. When you use the help command, for finding information, let's say we did help nth root, it gives you a very brief summary of what the function does and how to use it. Same thing if we did help for our own functions. If I did help frustum sav, it gives me essentially my help text lines. It tells me how to use the function. It gives me a brief description of what it does, how to use it, my inputs and my outputs. So it's really important that as a user of functions, we know exactly how many inputs we need to send the function. Because if we only send it 2 inputs, like if I did this, if I only sent it 2 pieces, it would say not enough input arguments because it needs 3. There's 3 inputs. And then I also want to know how many outputs it has. So once you fill all that in, then you're done. You go ahead. You wrote your first function. It's great. It's beautiful. It's wonderful. Okay, so let's do it again. Let's do our second function. Woohoo! Once again, I forgot to erase the comments on this line. Okay, let's go back to our notes and do this again. Okay, this one's a little bit more complicated just in the sense of the calculations, not the process of writing a function. So here it says write a function that calculates the frictional head loss, HL, in pipes where the friction coefficient is calculated with F, etc. And I have 3 equations. So I want to calculate this. This is my output, essentially. At least that's what my goal of my function is. So I go through the same steps. First, I want to figure out a descriptive name to represent its functionality. I'm calculating the frictional head loss. I can name it whatever I want. I'll name it calculate HL. It's not the most descriptive, but I'll just assume that pretty much everyone who's using this function knows what HL is. I'll just assume that. Not a good thing to assume, but we'll just choose that. I need to determine what my input parameters are. Okay, so once again, the input is identifying what information do we need in order to perform these calculations. So I'm going to look at all of my unknowns. I need F in order to calculate HL, but F is calculated with this expression. So I don't really need that as an input because I have my calculation to do that. I need L. I don't have a calculation for that. I need D. I need V. And then G isn't told to us, but I know that it is my gravitational constant, 9.81. That's a constant. So that means it doesn't need to be an input. I can just define that value inside of my code. Okay, so those are the pieces of information I need in order to calculate HL. So that means I'm looking at L, V, and D at a minimum. Okay, I know I need to calculate F, so let's see what I need to calculate F. I need something called E, or epsilon. This is the same D, so I don't need that one. RE. RE, however, is calculated with this last equation. Okay, so that's not going to be an input. Epsilon, D, same thing. RE is that. Epsilon, D, and RE. So addition to this, I need a value for epsilon. In order to calculate RE, I need V, I need D. Those are already given, or those are already in HL. And I need something called, I think that's the Greek letter of nu. You can correct me if I'm wrong. So at a minimum, to calculate these 3 functions, these 3 expressions, these 3 math calculations, I need this information. So that means that these are going to be my inputs. That doesn't mean I need to know what they are right now. It just means when these calculations are actually executed, I need that information. And then I'm going to determine what my output parameters are. Like I mentioned, we are just calculating the frictional head loss. So really, at the end of the day, I want HL to be my output. I can have as many outputs as I want, so technically I could also output F and RE, but I'm just gonna straight up only do HL. Okay, so I've got the name of my function, I have my inputs, I have my outputs. Now I want to write my function body. So let's go to MATLAB and write this function. So once again, just create a new script file. Or create a new M file. I shouldn't say script file anymore. A new M file. I'm writing a function, so I start with the word function, followed by open close brackets. Inside of those brackets, I put my outputs. HL. I can name it whatever I want. I could do H_L, HL. I could just do H. It really doesn't matter. It's just the name of a variable. Then equals. Then I type the name of my function, calculate HL, open close parentheses, and then list out my inputs. L, V, D, epsilon, and new. You could do lowercase v, it's up to you, but note, uppercase v and lowercase v might cause some issues. And then I need to end. Then, in theory, you can add your comments. You don't need to add your comments right away. Sometimes I like to write my comments at the end of writing my function. It's just a preference, but I'll write the comments right away. Calculate HL. Calculates the frictional head loss in a pipe. I'm going to use Mitchell's. Let's see what this does, right? That's how I do it. We'll see what this does. So put in my author. Oh, snap. Date, nope. 21, I forgot I typed the percent sign. My use case. New, it just says new. And then my inputs. You would list out your inputs. I don't remember what L, V, D, EPS, and new are, so I'm not gonna type those out. And then my outputs, which would be H, which is the frictional head loss. Does this save it? Let me, okay, so I'm gonna save my file. Remember, the name of your file should be the same as my function. So if my function is called calculate HL, then my file name should also be calculate HL. So let me save that. Okay, I don't know if this works. But, you know what I can do? Just put my comment lines in. Comment. Okay. If you figure out how to do multiple line comments in MATLAB, let me know. Okay, so there we go. I have my comments. They're not complete, but that's the idea. Like I said, I don't remember what L, V, D, and everything is. Okay, so now we write our code. Now we write our calculations. In order to calculate HR or HL, I first need to calculate F. In order to calculate F, I need to first calculate RE. So I'm going to start with calculating RE. My equation for RE is just V times D divided by nu. And that's technically the Reynolds number. This is a fluids equation, in case you're curious. Okay, now I have RE calculated. Note, I don't have value. I don't know what V, D, and nu are. That's fine. I'm just going to assume that they store appropriate values. They're not going to be assigned values until I use my function, until I have a function call. Then I want to calculate F. F is a really long equation. So F looks like this, which is really long. Just another tip for calculating long equations. It might help if you start with the innermost parentheses. So I'm going to start by calculating here. I'm going to start my code by typing this set of parentheses, and then I'll work my way out. So if you're running into issues on problem 1 for your homework and you're like, oh, I can't get over these parentheses, they're just too much that you're trying to calculate, start with something small and work bigger. So I'm going to start by calculating that middle piece. So EPS, or that last piece, divided by D, divided by 3.7. Technically, I could put parentheses around these, but I don't need to because it's just order of operations. A lot of students use too many parentheses. Really, you don't need to use them if you have something like 5 times 7 divided by 3, because it's automatically, by order of operations, it's going to do this first and then divide that final answer by 3. So I don't need parentheses around here. I also don't need parentheses around here. So that's my innermost set of parentheses. I know all of that needs to be in parentheses because that should go inside of a log function, or log 10. Then this log 10, points are not taken off for unnecessary. It's just much easier to debug and follow when you don't have lots of parentheses. Then I know that I have 5.2 divided by RE times that. And then in front of that, I have EPS divided by D minus that. And then I have parentheses around this whole thing, because that goes inside of another log. I'm going to make this big. In front of this log here, I have another 5.02 divided by RE. In front of that, I have EPS divided by D divided by 3.7. Then I subtract that. And then this whole thing goes inside of another log. It's a very long equation. Fluids equations tend to be long. This is multiplied by -2. And then this whole final thing is raised to a power of -2. So notice over here, I had 4 closing parentheses. Sometimes it's a lot simpler if we start smaller and work our way bigger and put it in parentheses as we need them in order to help us keep track of where things are. You can also hover over your parentheses. So if I go back and forth over this, I have an underscore that shows up. The other underscore showed up over here. So that tells me that this is the open parenthesis, and then this one's the closed parenthesis for that. Okay, that's my calculation for F. It's a little long, a little big. Lastly, I need to calculate HL. So HL, or just H is what I call it. H is my output. So I need to name it the same. H was F times L times V squared divided by D times 2 times G. I didn't define G, so I'm going to go ahead and define G up here, 9.81. I can comment that as meters per second squared. There we go. A couple things to point out. L, V, D, EPS, and nu were used in my calculations. They appear on the right-hand side of my calculations. H is my output. It appears on the left-hand side as my final result. R, E, F, and G only exist inside of this function. I don't need them outside of the function. They are just there inside the function only to be used inside this function. So let's use this function. Delete that. And let's say I want to do some calculations. So I want my result to be stored in H1. Calculate HL. I'm going to send it a value of 26.667 for L, a value of 2.065 for V, a value of 0.15 for D, 0.00036 for epsilon, and 1.02 e to the -6 for nu. So once again, let's save that. Let's run it. Step in. When I execute this line of code, it jumps into my function. It assigns the first number to L, the second number to V, the third number to D, the fourth number to EPS, the fifth number to nu. So we can see in my function workspace, those variables show up. It calculates RE, it calculates F, it calculates G, and it calculates H. So inside this function, I have 9 variables inside my function. However, inside of my script file, the only variable that I have is H1, which just stores my final calculation, which is 0.9673. And then I can copy and paste this and calculate for a new set of values and keep going. There we go. That's how we write functions. That's how we use functions. For your homework, you will be told what to name your functions, which means you need to have that file named the same. So you'll just submit the file that has your function with the same name. So Johnny, that's a really good question. When we give you problems like this, we aren't necessarily going to explicitly ask you unless it's an obvious situation where you need to work out the units. But in general, if we don't give you units, assume that you don't have to worry about those conversions unless you're explicitly told. Okay, some final details to go over. So for your homework, you won't need to write the function call. For the homework, you would just submit the function file. But you should know how to use functions. For one of your homeworks later on, you'll need to use one of your functions in another homework. But in general, when you submit your homework, you just submit the function file. Okay, let me go back to the notes, just some vocab for why this is useful, the way that functions are created as isolated pieces. Here we go. So when I say a function has its own workspace, that's called a local workspace. That's just isolated to the function. The variables inside my function are not accessible inside of my script file. The variables inside my script file are not accessible inside of my function. So it's a local workspace, it's isolated. And the command window and script files use what's called the global workspace. And it's nice because what this does, I'll just skip over that. It minimizes what's called side effects. It minimizes the locations where your variables can change, where you might run into issues. Is there a convention for using spaces between operators? There is no convention that I know of using spaces between operators. It's really just programmer preference, programmer independent. If you program in like an industry at a job in industry, they will have programming standards that essentially tell you what your code should more or less look like. They might have an indicator for how variable names should look like. They might have an indicator for how for spaces, although probably not. So there is no convention that I know of. So just make it clean and clear. You notice I do different things in different locations. So yeah, so functions, they're used to help minimize, to help debugging. You know that this function works. There's no issues with this function. So it's got to be somewhere else. There's less variables that show up in your workspace when you break your code up into functions. And it's easy to reuse the code over and over again because you don't have to recopy, retype it, and repaste it. So you can have as many input variables as you want. It depends on what makes sense. Sometimes you don't need any information in order to do a calculation. So you would have 0 input variables. Sometimes you don't need to return anything. You would just have 0 output variables. Oh, I do want to point out that if we have 1 output variable, we don't technically need the brackets. That's the one instance where we don't need the brackets, but it's good practice to still have them. Notice up here, I didn't need to put H1 in brackets. Okay. So that is for functions. Hopefully that's really useful to you guys. Like I said, functions do tend to be a little bit more challenging for students, but I really tried to break it down and help you guys understand what's going on behind the scenes. Hopefully this makes sense. With that, I will see you guys next week. I will have the videos for Friday posted. I will send you an email again on Friday just outlining what you guys should be working on. And I'll see you guys on Monday. I'll stick around for some questions if you guys have any. I know Shnatube had a question on homework 2 that I might be able to answer. Okay, Benny, off-topic question. Yes, so the MATLAB program automatically opens the MATLAB, the one in your documents that it creates. Google that. There has to be somewhere in the open up MATLAB file. I also know that if you open up a file from, so like if you open up a MATLAB file from like File Explorer or Finder, if you double click on it and it's set up appropriately, it will open up in MATLAB with that as its current folder. You Google it. I don't know off the top of my head how to change the default current folder. That is a good question. Sorry, I don't have a better answer for you. So, Nick, that's a good question. You're going to calculate the identities twice, one for each set. So for identity 1, you have to calculate it for set A and set B. For identity 2, you have to calculate it for set A and set B. So there's 4 different calculations. 2 for identity 1, 2 for identity 2. Homework 2. Oh boy, yes. Homework 2. I haven't looked at homework 2 since I finished putting it together. Let me open up homework 2. Do we need to output? You can't. You can't output units. You can't units aren't numerical, so you can't output any units. You just return the numbers. The user, whoever's using the function, should know more or less what the units are going to be. That's where you might add some comments. So when you have when you're listing the outputs, you would like comment and say returns omega in hertz, returns current in amps. But you can't explicitly output the units because you can't have a variable that stores 2 amps. You just have a variable that stores 2. Good question. So you should submit the homework by attaching 2 M files to the same assignment. So not a zip file, just 2 M files to the same assignment. It needs to be a .m. You can't have a .docx, you can't have a .txt, it needs to be a .m for it to work properly. Any final questions? That would be best practice, TDEL. If you only submitted 1 file in 2 separate submissions, you should go back and submit 2 files to 1 submission. That would be significantly appreciated. Yeah, I glanced at that, Benny. I didn't read your comment earlier. Comment continuation. I think you can continue your comment on the same line by typing. I'll look into it. I've never done it before. There's got to be a way to do it. For MATLAB Online, yes, you have to download the M files to submit. So you, in your current folder, in your MATLAB Online, you'll click on the file, and then in the Home tab, there should be a download button. You'll have to do it twice separately. MATLAB Online they're still working on it. It's a relatively new product, so they're still working on it. But yes, you will have to download your files. They'll show up in your downloads, and then you can submit those. Yeah, I'll have to look into it. There's got to be a way to do it. I don't know. I've always just typed %, %. Ah. That makes sense. Any final questions, comments? So, Benny, so if you press, comment continuation, you can just keep typing, but if you want a comment to be in a separate line, pressing enter, you have to retype the %sign. So what Mitchell is talking about is if you don't want to have to do that, there's a way for anything you type after a certain line to another location, everything to be considered a comment. It's not essential to programming. It's just more of a useful thing. Okay. I'll have to, maybe I'll demonstrate that next week or the week after. Okay, so with that, I think I'm gonna go eat lunch. See all of you guys on Monday.